Hey, and welcome back to my YouTube channel. This is Tremor, and today we are going to continue with the Game Engine series. Since we implemented the sandbox project last time, this time we can actually start to implement some functionality. And we are going to implement a small routine today, which will create a couple of triangles and will change their color over time. And without any further ado, I'm going to put myself into the bottom right corner and we will start implementing. So where did we stop? Let's just run the program. It's just a single triangle in the middle of the screen. All right. So if we want to have several triangles, we have to obviously change how we supply data to the engine, to the renderer. And if we look at the renderer, we see that this triangle is like statically put into the code. It's like in the code. There's nothing we can change while the program is running. We can't also add further triangles because the vector is static and there's no way for us, or it's not a static vector, but there's no way for us to put more values in and with that to display more triangles. So we have to change that vector first and also implement functionality to supply data to it because like right now the renderer only has init and a draw function. So let's start with these functions. So we just add a function or two functions. Well, one function for now, a static void, add vertex data. So, and we are going to give it two values, x and y, and those are going to be float values. So, and just because I know that this will be annoying to always push around these two values, we are going to make it a bit easier and we are going to implement a small helper class here in the renderer file, which will be a struct, and we will call it vector2d. And this, not vector, but vector. And this class will just contain two float values. And they will be initialized with 0. And we will also add a default constructor. And that's fine for now. And now we can just say, you don't get two float values, you get one vector 2D, and we just call that coordinates. Now we implement the function. And all it does, it adds those two values to the vector inside of the static render storage object. And plays back, and we just say coordinates dot x and duplicate that file and just push the y value in there as well. So now we just remove this here. So the vector will be initialized without any values. And remove those 5 lines. And this should compile now. And now we don't see anything anymore, because we don't supply any data. And let's keep that. Let's just get that back and copy it. And I'm going to put that into the sandbox layer file, because this is where we will code from now, in the update function inside of the sandbox layer. And I'm going to put that here, and I'm going to put it into how was the shortcut? Like this. There was a shortcut for, doesn't matter. Just doing it manually. Okay. And now we just say Lucy renderer and add vertex data. And we know the vector class because the renderer file is already included here. So we can just say vector2d and just create a temporary object. That is absolutely fine. And copy those two values in here. That's be like that. Ah, no, that's the... Okay, what's the problem? Yes, of course, there is no fitting constructor here, obviously. So, that's the wrong file. We just add another constructor, and that one gets one float value and another float value. They have the same names now. That is bad. So we just call them like this, and just add the assignments here at the back. And that should be fine now. And the error should vanish as well. Let's build that. Okay, now we just do that 2 more times. And we just use the other values. That's 0.5 and minus 0.5 and 0, 0f by 0.4f. Okay, those are correct now. Let's run it and see if we see the triangle again. There we go. So that works already. So now we can remove this here, and we will add a second triangle. Let's move this one a bit to the left. I'm going to move this to 0.8. And then it's just going to go to 0.2. And the height is going to be the same. And this should be... the middle of that is now 0.3, negative 0.3. So this should be the same triangle now, just shifted towards the left a bit. Yes. Let's make it a bit smaller. Let's put it just so that it goes to, let's say, just a 0. And then the middle would be 0. Well, it's not an... the middle should be negative 0.4 now. Yes. And now we just copy these 3 calls. And we start at, let's say, 0.2. And we put that to, well, let's start at 0.1 and we put it to 0.9. Actually, just like that. To 0, 0.8, and the middle is now 0.4. And this should give a second triangle just to the right of it. And it doesn't. And I also know why. The reason why this doesn't work, why we only see one triangle still, is because right now the renderer is only told to draw one triangle. We are telling it, send 3 floats over there. No, send 3 pairs of floats over there. So 3 vertices times 2 components, 2 float components per vertice, times the size of float. But now it's 6. So we changed that into 6, and we also tell it to only draw 3 vertices. So it has to draw 6. And if we start it now, it's going to work. And there we go. We have 2 triangles. They meet each other directly in the middle of the screen in terms of like the horizontal axis, and they both have the same distance to the left and right border of the screen, of the window. So having fixed this now, this doesn't really fix our problem, because now we can draw 2 triangles. But what if we want to draw 5 or 15 or 500? Well, we need to make this dynamic. So we are going to introduce a couple of constants here. We have an integer constant that is called components per vertex, and it's 2. And we have, so let's say number of vertices, let's just call it number of vertices. And this is 3. We can just add a couple of comments here. number of vertices per triangle and number of components per vertex. Okay. So now we take these constants and already put them in here. So this is the number of components. So as render storage components per vertex. And here we need the, we actually need the amount of components that are inside of the vector by now. So we just say size, the size of the vector, and we divide that by the number of components per vertex. And that now, if we just debug here, inside of the vector, we have 12 values, meaning per vertex, we have 2 components, means 12 by 2 is 6, and that's the number that has to be here. And if we have, if we would have like 3 triangles, then we would have 18 components in there, and 18 by 2 is 9, and then we have to draw 9 vertices because each triangle has 3 vertices, so that should work. If we just run this, then we should see the 2 triangles. And just for a test, let's go back and just remove that. And now we should only see 1 again, and it should still work. There we go. And of course, I forgot something. We also have to change the number of vertices to draw. This has to be just this formula. Now, let's get the second call back, and we should get 2 triangles again. Yes. And if we copy this the 3rd time now, or well, the 2nd time, let's just move this like to the right. And just move this to 1 and put this on 0. And now we should see a 3rd triangle just shifted to the right edge of the window. Yeah, there we go. There it is. So now let's just implement a simple routine to generate a dynamic number of triangles. Let's just say each triangle is going to be have a width of 0.3. What am I doing? Let's say its height is going to be 0.5. And let's also say we want to generate 6 triangles. Let's make a for loop. And now we need 1 call of this. And we are going to generate just cut that out until I have the solution. Okay, stop. 1, 2, 3. Just start again. 1, 2, 3. And we're also going to need a starting position. Let's say it's -1. And we are going to need a, let's call it just base height. That's where or base position Y, that's where they sit, like the line on which they all sit. Like they will all sit on one horizontal line. Let's just say 0.5. Okay. Semicolon here. And now, so the first two vertices, they will sit on the base position. And this one will start at so this is the starting position, and we also need a current position. And we start that at -1, or we start that at starting position. Okay, so this is the current position plus well, that's just the current position. And the second vertices, like the right corner, the bottom right corner, is going to be the current position plus the width. And then the last line will be, this has to be in the middle now, so we have the width. And this will be at base position plus triangle height. And let's set that to 0, the base position. And let's remove those three. And then we see if this actually looks how it's supposed to look. I don't think so. Oh, look at that. Okay. And now the only thing we have to do is we have to increase the current position by the triangle width. And this should generate a couple of triangles next to each other. There we go. 1, 2, 3, 4, 5, 6. Now we want to change the color. Where does the color actually come from? The color comes from the shader, and right now it's set as a static value inside of the code. It's a reddish hue. So what do we have to do to change the color on the fly? Like if we want to give a value to the color, if we want to have every triangle, for example, to have a different color, or just be able to change the color like at all, because like right now it's fixed. We can change it here. If I put, for example, 0.4 on the red value, you will see that it's another shade of red. It's like a brownish pink color. Okay, so for this we will need to change like both shaders. First of all, right now we only supply the position as a layout location. We will need a second location here, which will have the index 1 and will also be coming into the shader, and it's going to be a vec3, and it's going to be called in color. So, and then we need a same thing again, but now in the outwards direction, like out from the vertex shader to the fragment shader here. And this is the same thing. Well, not the same thing. It's just called out vec3. And then we just call that out color. Now we copy this line because we also have to assign the value that's coming in to the value that's supposed to go out to the fragment shader. So we just copy that line and we say, and we just say out color equals in color. That's all we have to do. Just also use the right names. And that should be all. And now in the fragment shader, we just add an in vector, like a vector coming in, which has to be of the same kind than the one that is going out of the vertex shader. So we use a vec3. We are calling it in color. And now we are going to just change those three values into in color. And GLSL is providing the functionality that you can create a vec4 based on a vec3 and an additional fourth value to complete the 4D vector. And what should happen now is we should still see the triangles, but they should be white. And there we go. You can also see in the background there's an error now because we are not supplying any value here. Okay, let's do that. What do we have to change to actually make that happen? Well, we have to change the definition of our vertex buffer first. That's the first thing. We are defining the vertex buffer here. And like just right now we have like one attribute, or yes, like one attribute which is made up of 2 components. And we can actually change that here now. We can use the constants we had now, components per vertex, and we change it here as well. Let's just go back and see. Those were the same numbers before. It's a 2. Yeah, so we just change those 2 values here as well. And we can also change this into number of vertices. And then we should be able to remove those 2 values without breaking anything. Let's just compile and run again. Let's see if it still works. Oh, still works. Okay. So we only say that the vertex buffer should be 2, like each attribute is comprised of 2 float values. And there's only one attribute, which is the position, the x and y value being the 2 components. So we just copy that line. We increase the attribute ID by 1. And now we say, and now we have 3 components, because a color is comprised out of a red, green, and blue value, RGB. So we just say 3. And the same goes here. And we just comment that position and color. So now we supply 5 float values. The first 2 are the position, the other 3 are the color. And we also have to enable them. I'm just going to move that here and then move that and then copy it here. Let's just check it. We have 3 components. They are made of float. They are not normalized. And the size is 3 times the size of float. And now we have to change the offset. It's not 0 anymore. It's now just 3 times the size of float. We're missing a bracket. Okay, let's compile that. Well, it's going to build anyway because this is only been executed on the graphics card anyway, but it should still render. Each set is made up of 2 floats which represent the position and 3 floats which represent the color of the current vertex. And what the graphics card does, what OpenGL does, is the colors are only there for each vertex. So per triangle you have 3 colors you can define, and OpenGL is going to interpolate the colors between each vertex. So if you supply different colors for each vertex, for each corner of the triangle, then you will have like a gradient between the vertices. Okay, so this is supplied now. So now we have the renderer set up, I think. We changed the shaders, we changed the buffer layouts, and this is the buffer size. So I realized I made a couple of mistakes and we have to change some stuff. So first up, we're going to rename this constant into vertices. We can also do that with the rename. That's a refactor. Vertices per triangle. Okay, now we need another one. we will call max number of triangles, because we have to tell OpenGL how large the buffer is supposed to be. And let's say we are just going to have like 10 triangles for now. And here we tell it how large the buffer is supposed to be. So we just say max number of, copy that in here and then an asterisk in between. So we say number of triangles times vertices per triangle per times components per vertex. So if we have, let's say, three triangles, we have 3 times 3, and then we have 5 components. So that's 9 times 5 is 45. And this we have to change as well. We don't have 2 components per vertex, we have 5. We have 2 components for the position and 3 for the color. So we change this into 5. Now we have to change this, like the vertex attribute pointer definitions here as well. So we go back to 2 components for the position. And here we have to change this. The stride is always how far we have to jump to get from one vertex to the next. So the stride is always the number of components per vertex. So we say components per vertex times size of float, and that's going to be the same for all the calls. So this one gets the same, because we always have 5 components per vertex. The first vertex attribute has 2 components, and the second one has 3. 2 for the position, 3 for the color. And that should be it here. And the stride is also 2, because the first attribute pointer is 2 components wide. So we say the pointer here starts at the end position of the second component. Okay, so now we also have a mistake in the shader. We call the out vector in the vertex shader vertex color. Change that down here, because they have to be named the same. So the in vector in the fragment shader is going to be called vertex color, and we change that to vertex color. So if we build now and run, this should look like this exactly, because now everything is messed up, because we are not yet supplying the color to the graphics card and also not to the shaders. So now the attribute pointers, they are going haywire, because they are only getting the values for the position, but we told it that it also gets the color values, and it doesn't yet. And that's what we have to implement now. So we are going into our renderer method, and we are going to add another function called add vertex color. And we're going to rename this here into add vertex position. These are going to be the same functions in the future. There are also going to be more vector classes, but I don't want to spam the code now with like useless classes. So we're just going to change the name of this function, and it should change all the calls too. And now we have this function to supply the color, and we are just going to give it 3 float values, R, G, and B. And we're going to copy this call 3 times and just say emplace R, emplace G, and emplace B. Now we jump into our sandbox layer, and behind every call for a position, we add a color. And let's just say we add the color is going to be whatever, 0.3F, and then just, all right. What's the problem here? Yeah, we didn't change the name. Okay. And we just add that behind every, or after every position that we add. So this is one vertex. Let's just comment that. First vertex, or let's say bottom left vertex. bottom right vertex, and this is the top vertex. Okay, build that, and it could actually be that it will already be running. Ah, that looks fine. We have a gray now. Let's say we want a blue. There's a blue. And this works already. So now let's see what happens if we give it different colors for the vertices. And we get something like that. You see a gradient. Let's make them a bit more. Let's just do it like that. So this one will be very red, the bottom left. This one will be very green. That's the bottom right. And the top will be very blue. And there we have a proper gradient. And now the last part of the video, have it change over time. To do this, we are just going to create instead of the sandbox layer, we are going to create an object. Or we're just going to take these three values, just going to make it really dirty and really cheap. And we are going to turn these into class variables. Give them like an underscore, so we see that at the back. And now on every engine loop that we are doing, we can remove those, and we just say the color step is 0, 0, 1, and now we just give them these values. You can also just rename them in color R, so that is a bit more understandable what they mean. And now we just say color R like this. And here color G and color B. No, what did I do now? And now we just paste this over this, and at the end we just say color R plus equals color step. Duplicate that twice. Change the names. Underscore at the end. And this should lead to the triangles changing their color over time. And of course, it doesn't work. I think it actually is going too fast. And it obviously is, because if I just click a couple of times and look at the value, it's now also, if we look at this, you see them become gray. So let's just do this a couple more times. Yeah, so it's definitely going too fast. That means we have to step down. Let's do it like this. They should become lighter at some. Now it probably is way too slow. Let's just go like this. And they will also only be gray, of course. Right here, there we go. They go from gray to white. If you are wondering why they are becoming invisible for a second, because the background color that we are using is probably just a gray. Where is the, yeah, it's here in the, yeah. So that's why they go invisible after a second. If you look at that now, they go invisible because now they are the background color, and then they become lighter and they turn white at some point. There's also a small mistake here because we have to cap the values. We have to clamp them. So if we go back to the sandbox layer, we just have to say color R equals is it if it's bigger than, if it's larger than 1, then set it to, then set it to 0. If not, then it just remains color R. Because there, like, values above 1 for RGB are not defined. So it's pretty much undefined behavior. What's going to happen there? I guess they're just going to stay white. Like everything above 1 is just going to be interpreted as 1. RGB, so they should never get higher than 1. I guess we can just increase that a bit. Oh no, we can actually say if they are... Oh yeah, it should actually happen. They should go back to black if they go over 1. Oh, there we go. And now we could obviously say, just for example, multiply that with 2, and maybe multiply that with 2 and that with 2. So it's not just exactly. So there you go. It's a basic effect. Like it's nothing like special, but it just shows you how you can generally now use the renderer to do stuff like this. Like this is already in there. We can render triangles. You can also render quads. We have seen that last time. And that's going to be it for this episode. I hope you liked this. Like it was a bit... I had to look some stuff up. That's why there are some breaks in there, especially the stuff with the renderer and the vertex attribute pointers. I always have to look up after a couple of months when I didn't look at this stuff. I have to look up what like the stride actually means. So I got a bit confused there as well, and I'm sorry for that. I'm going to put myself into the camera full screen mode again. I thank you for watching. This is a longer video again. I hope you liked what you saw. And if you did, then like the video and subscribe to the channel. And the next video is probably going to be, we're probably going to rotate these triangles. So they all rotate in different directions, and maybe I make them move over we make them move over the screen too. And I would say I wish you a nice day and see you next time. Bye bye.